Good morning, everybody. How we doing? My name is Andy Knight. I'm the Automation Panda, but you probably already know that from yesterday. This morning, I'm going to talk about how we can reimagine automation. As many of you know, I'm from North Carolina. I work at a company called Cycle Labs. I'm building test automation that is awesome. Come talk with me about that later. Oh, there we go. So, last I checked, the calendar says it's 2025, right? We've had this AI thing for about 2 years. The hot newness with that is agentic stuff. World is still exploding. That doesn't change. But I need to tell you, I'm actually visiting from the year 2035. That's right. Not only did I come all the way up from North Carolina, I came from 10 years in the future because I'm here to tell you what happened with automation in our space, so that y'all can be inspired to carry forward in good directions with it as we move into the future of this great new AI world. Come on. Sorry, the clicker is a little funny today. In the future, we fix this problem, I promise you. And so what we're going to talk about today is primarily automation. I'm not going to talk about what happened with politics or other things or the Orioles or whatnot. We're going to talk primarily about what happened with automation over the next 10 years. And there's a couple aspects we're going to talk about. Come on, man. There we go. But we're going to start off by talking about test automation and pipelines and builds and that kind of thing. Why? Because I am the Automation Panda and this is my base of power. I have focused a lot on testing and quality. But we'll also expand to talk more broadly about other kinds of automation that came out up to 2035 and have really helped things. So let's start by reviewing the history of where testing and automation pipelines came from. Then we'll come up to your present day of 2025. And then we'll carry forward into the future up to 2035 to see where things went. Oops. All right, so in case you missed it, the whole idea of software testing really started as its own idea back in 1979. There was this great thinker at IBM, his name was Glenford J. Myers, and he wrote this seminal book called The Art of Software Testing. Has anybody read this book? Neither have I. This book is older than me, but not as old as my car. Whew. But what was key about this book is that this was the first major time there was a separation of ideas between debugging and testing. Where debugging was the idea that you would step through your code line by line, possibly during execution time, to figure out what it's doing. Whereas testing was meant to be more of this after-the-fact check. That you are interacting with the system as it is and verifying that its behaviors work according to some expectation. And with this, we have the separation of the roles between a developer, someone who would write code and possibly debug, and the role of a tester, someone whose main job it is to try to exercise the behaviors in a system, try to break it, try to write a set of test cases or specifications to say this is the way it should be and point out when it's not matching up. And so from this point forward, we see that there are entire career tracks separated between development and testing. And at this point in time, everything was tested manually, right? There was this idea that the testers didn't necessarily need to have coding skills. It was certainly a plus. But there were plenty of people who were very successful testers who literally went in with grit and common sense and did a good job. And this was how things operated roughly from the 80s and the 90s. Then in the 90s, something happened. Does anybody know what happened? We had a big revolution of object-oriented programming. Was anybody there for that? I was still a kid, but I felt the effects later when whoa, sorry. Yeah, that's how I felt about it too. The jokes are free. No, but in the 1990s, there was greater maturity in how people approached the building of software products. And the main paradigm that took hold was object-oriented programming, because it was the idea that we can build larger, more scalable systems in more reusable ways. And so there were It was in vogue. Like Smalltalk was this kind of small thing on the side that people were like, wow, look at how cool this is. But then Java happened and that took over, and it's still kind of embedded in many places, right? We can't seem to get away from Java. When I went through school in the thousands, like that was what education all was. Everything was Java, right? But with the object-oriented revolution, we also had the rise of unit testing. Right? Not to say that people didn't test their code before, but mostly in whatever this dude was talking about, he was talking more black box typically, whereas unit testing was much more white box, right? The idea that you're testing the code itself. And so you have frameworks like SUnit for Smalltalk, and then you had JUnit for Java, which was based on SUnit, but really we all know because Java took over the world, JUnit also took over the world. I mean, to this day, in our CI systems, how do you publish a test report? Export to JUnit XML and let the CI system just kind of magically render it. It's what we do. That's how entrenched this was. And so unit testing as a practice kind of went hand in hand with development. Now developers are supposed to write unit tests. And so the XUnit style of framework spread across all languages. You've got NUnit and C#, you've got unit test and PyTest, you've got, I don't even know what else is going on. They're just all over. But the thing is, unit testing was primarily considered a developer activity. Am I right? It still is today. Can you imagine like a black box like QA role writing unit tests? Ooh, not so much. The reason why is because these tests test code. They don't test features, they test code. And who writes the code? The developer. I keep pointing at the screen. There we go. I need to point here. I'm sorry. I'll figure this out. I'm a professional speaker. I promise. All right. So where did it go from there? Into the 2000s, we started seeing a shift of automation out of just white box unit testing into black box test automation, where we're testing more features and products and things rather than just code. Because the thought was, well, hey, we have these cool test frameworks like unit tests, or like NUnit and JUnit and SUnit and whatever kind of unit you want. Can we do more with that than just unit testing? And the answer was yes. So long as you have libraries to interact with the thing, you can test anything you want. And people are like, let's try this. And so what you have is that your more traditional QA testers started combining test frameworks with other black box test tools. And this really also kind of coincided with a lot of web development, Web 2.0, if anybody remembers that phrase. Again, I was still kind of young, but like that was a thing. Like, oh, dynamic web, look, you can make the page dance. It doesn't have to just be a static file, woo, right? And then you had certain tools like Selenium come out. Oh yeah, Selenium was more like late thousands, but it's precursors of WebDriver and whatever other projects that became Selenium. They were there, right? Because browsers were becoming more important, more standardized, and people wanted to actually test their web apps. Gee willikers. And so then in the thousands, you have the rise of this new kind of role, and that was of the automation engineer, or a test automation engineer. And so there were now on your QA team, you would either have testers learning automation, or you'd literally just hire automation engineers. And a lot of the more old school manual testers were afraid of losing their jobs. As with every new technology, somebody's afraid of losing their job. And some of them do, but most of them don't. They just learn and adapt. But at this stage, by and large, the projects were pretty trash. Believe me, I've worked on so many Selenium projects. I have created trash projects. I can say this. It's okay. But the problem is we as an industry weren't as mature enough to understand some of the complexities in what it takes to build a good test automation project. And so there was a lot of really bad automation code. But things got better. The clicker didn't, but things did. In the 2020s, we have the rise of continuous integration, and with that, continuous testing. Everybody's favorite friend, Mr. Jenkins, right? For those who are too old, this is not Ask Jeeves, this is Jenkins. Right? Oh, I know. Oh, and so CI was awesome, right? We stopped using Apache Ant, we started using Jenkins, and now every change that we would submit would get automatically built into something. And then because we had our unit tests, we would automatically run the unit tests with it and give code coverage with it. And the world was right. It was great. And the code coverage we quickly found out meant nothing. And so then we started adding those black box tests to the pipelines, or we said we did and we didn't, but some of us did. All that to say, continuous integration really changed the game. We had a whole DevOps movement start to come out of this, didn't we? I think the word DevOps started coming out in 2007-ish. I looked that up on ChatGPT. But it was during this time that we could start to move more quickly, move at scale. And testing really became critical to this because with continuous integration, we could push new features at the speed of light, but without testing, we could be pushing garbage. Regarding the automation, we also figured out some key things. We solved things like the flakiness and the waiting problems, or at least we knew how to and we didn't actually solve them. We also realized that, hey, your tests should be smaller and more atomic, and what really matters is for them to be robust. We don't need to have these lengthy grand tours through our application like we did with manual tests. We really want short, sweet, to-the-point tests because they're less likely to fail. And also in the reporting, we can see more clearly what behaviors fail when they do. So we were able to develop more automation, but these projects started becoming more complicated, right? And so we started realizing that, oh, there's not only are there the test cases and the test projects we need to worry about, but there's the pipelines as well. And so not only did we see the rise of DevOps roles, we also saw a new role in the software development engineer in test, a developer who focuses on these kinds of things come about as well. And that's where I entered my story. I graduated in 2010, and for most of my career, I was an SDET, hence my focus on testing. Come on, man, there we go. So as time went on, we progressed into the early 2020s. Here we are in your present day. A lot of the tools in the past decades since the continuous testing revolution really started focusing on making testing easier. They started focusing more on the developer experience, right? We have these beautiful platforms, these beautiful portals we can go into. It's easier than ever to spin up cloud resource. In regards to the testing frameworks, we don't just have JUnit anymore. We have some very nice, refined frameworks like Cypress and Playwright that are basically eating Selenium's lunch, right? Why were these tools becoming more popular? It's because they made it easier to do tests that were more reliable. Oh, surprise. No wonder they caught on. And so what we see is companies are building these massive platforms at scale for deployment, for execution, for pipelines, for testing. And we also saw that developers actually started doing more testing, not just unit testing, but black box testing. Developers started taking more ownership of these pipelines, or we hoped they would. We all know how these things go. We have solved many of the tech problems. We have still not solved the people problems. The people problems never get solved, not even in 2035. The hardest part about tech is the people.
Yes.
Amen.
Amen.
Amen. This can be interactive. It's all good. So here we are in 2025. What happened after 2025? Where did the world go from here? Autonomous. Things started moving in an autonomous direction. What do I mean by that? Well, for the longest time we've been talking about automation. The idea of automation without a ChatGPT definition is where things just kind of do their task on their own, right? I push a button and it just does it, right? You think about cars. I'm into cars. You can have a manual transmission where you got to shift 4 on the floor and smack it down to get in a reverse, and you have to be conscious of your revs and your miles per hour and all that kind of stuff. But then there's this automatic transmission. You put it in drive and you just go, whee, and the car goes, right? How many people actually drive a manual transmission today? There's a couple. Very nice, very nice. As I mentioned before, or maybe I didn't, I'm into classic cars. I have a Volkswagen Beetle, the old kind. Currently, its transmission is on the floor in pieces, and I'm calling people to rebuild it. But automatic means it just works. You don't have to manually push buttons. Yet when I look at most of the automation that is in place today across different companies and orgs, how much of it is really automated? Some of it, triggers automatically based on if you pin a pull request or whatever. But a lot of it still requires manual intervention, either to build it or to trigger it. Is that really automated? No. That's why we have a new word to kind of nuance that distinction of autonomous, in that technologies, I believe, are going to be working towards removing as much of those manual controls as possible, where things can be generated automatically for you. Things can just go off and execute their tasks without you having to poke and prod. That's what I mean when I say autonomous versus automated. Does that make sense? So that's where things went going towards my present day, 2035. So, what did this start to look like? Well, y'all have had ChatGPT for like 2 years now. Yeah, very quickly it took over. And even I think in 2025, there's this whole agentic thing, right? That's like the new thing. But if we're talking like 2024, the LLMs, the ChatGPT, the Copilot, what they really started enabling, particularly testers to do, was to start generating test cases, right? The idea of just raw prompt engineering. Hey, ChatGPT, I have this particular feature. It's supposed to do this, that, the other thing. Here's my design spec. Here's my document. Can you write some gherkin scenarios for me in given when then format? And the thing is, the LLMs were really, really good at that. You give them docs, you give them information, you give them context, and when they screw up, you say, no, ChatGPT, you're wrong. I meant it like this. And it says, oh, thanks. Haha, I'm so sorry. Here, try again, right? And with some very light prompt engineering, we could get some pretty good test cases out. And that was both in terms of unit tests, where, you know, Copilot could look at your code and just be like, oh, I'm suggesting a unit test case for you. Thanks, Copilot. But also to black box style tests, where it's like, hey, I'm trying to build a feature. What do you think would be appropriate attack vectors for this, right? And it does it very, very well. And so at first it was rough, but eventually these tools started developing pretty good test cases. And these didn't replace testers, it just made them more effective at getting their docs done. But then, geniuses that we were, we realized, hey man, wait a minute, why would I simply generate test code when the clicker would work? Oh, come on, man. Why generate test code when I could just have the bots go run the test cases for me? That was mind-blowing, and that's what we started calling agentic AI, right? There's a nuance between asking a question to get information from these AI things. Hey, ChatGPT, what would be a good test case? How could I cover all these different equivalence classes? What do you think about this attack vector, right? There's a difference between the question and the task. Hey AI, just go do it for me. Just go run tests. I don't want to have to be click, clack on the keyboard. Just you run it for me and tell me what happened. And that is what agentic AI really enabled. And that was where the autonomous piece came in. I didn't have to take the output from ChatGPT, put it in a test case management system, and then go click, clack on the keyboard to verify that things did it or not, or to go write some playwright script to go execute it. AI's just like, yeah, that's the test case. Here's your playwright script. I ran it for you. Oh, it failed. And this is where it failed, and this is why it failed. Thanks. That's the world that we're living in 2026. So, in order for the AI to really do well with that kind of testing, it needed more than just you as the informed human to tell it, here's what my feature looks like. And there are really 4 main, what I call learning sources, in order to assure quality well, or else you get really bad tests that go off the rails. The first thing it needs to know is system behavior. There are certain things in general about browser-based web apps, about API services, about mobile apps on your phone, and about those whole Google glasses that are coming out in 2028, right? There are certain aspects of system behavior that are standard regardless of whatever your application is, right? On web apps, you click buttons. On your phone, you tap and you scroll. On Google Glass, you just kind of blink twice and crazy things happen, right? Those are all things that these AI agents can learn about. This is how systems work in general. These are the bounds. These are the rules of engagement. And so systems, the AI needs to learn those kinds of things. So at the very least, it can bop around your system like a Roomba and cover the whole area unintelligently. But then there's also human feedback that we need to give, because there's the general application context of how the applications in general work, but there's also the specific context we need to give of, here's how my app works. I'm building this cool little widget thing that goes, wee, right? And we as the humans know that when we're building it, and so we need to be able to present that and provide that to the AI for its learning to say, oh, so I know web apps in general work like this, and I know your thing goes, wee, like this. Those two things together, now I know how to test it. Whoa. So sorry. Oh my gosh. I'm way too animated with this. I'm just going to put it in my pocket. It goes wee! I'm so sorry. If I break the clicker, I'll buy another one. I'm sorry. But the general context with the specific context meld together to actually help the AI agents know this is what this kind of app looks like, and this is specifically the behavior that I need to cover. So those two things need to come together. Then you had the development artifacts, right? And what I mean by this are all the things that you generate as part of product development that are not the code itself. Oftentimes, we like to think of software development's main output as being, I have some runnable application, right? I have some code that I've written. But there's way more that goes into product development than just coding, right? There are all of the user stories that you wrote. There's all the bug tickets that have come in. There's all the feedback items that have been solicited from the field. There's all the conversations you have with your team. There's your entire wiki or Confluence site full of very important information. There's design specs, there's documents, there's requirements. All of that is additional context that can be fed into this, because these AI agents might not actually be working with the built thing yet. You might still be in the process of building it. But then finally, after you build your system, there's a fourth thing, your observability data. What is the thing actually doing out there, right? How is it actually behaving? What are all the logs? What are all the traces? You know, is it actually performing as well as it should? Are your users actually taking the paths through your system that you expect? And so that's a fourth prong of information that these AI agents can learn from in order to understand what you're trying to build, in order to provide good feedback on its quality and its functionality. So for a while, we let the AI agents just roam free on our apps, hitting on it almost like Chaos Monkey did about, what was that, 2010s? But then as the humans, we realized, wait a minute, hold up. I think we have a new paradigm or approach to quality and testing. You see, these AI agents, these autonomous bots, these agentic playwright whatevers, they're very good at interacting with the system, about pushing and poking buttons and going through like crazy. And they kind of figure out what user flows look like based on all the other things they've learned from those four sources. But the one area that they're not good at is really knowing if something is good. They can tell you how something works, but they are not very good at judging, is this good experience? Is this the right thing to build? Does this actually meet business objectives? Does it deliver meaningful value? Who's good at that? Humans! I mean, how many times have you used an app and been like, man, this thing is terrible? There are certain apps I could name drop. I probably shouldn't. I should be polite. Come talk to me after. But we all have that experience of, man, why doesn't the thing, right? Frustration, right? We as humans, we know that in like 3 seconds, flat. I mean, it's like, if we download an app and it does something like that, we're just like, delete, not even gonna try it, we're done, right? Machines will continue to hammer it for hours on end and be like, here's all the different things I found, here's all the different errors in your trace, here's all the exceptions, right? At that point, it's like, this is too much. This is overwhelming, right? Thanks, intern. We've realized that humans and machines are good at two opposite but complementary things. The machine can go pound on it forever and find all the problems and handle all the tasks of execution. The humans need to determine, based on that output, hey, was this good or bad, right? And so for the longest time in our test scripts, we've always written interaction code followed by verification code. click this button, do this, assert that, assert the other thing. And a lot of times what happens is we found that when we would change behavior, all the assertions break, right? Ooh, we hard-coded our decisions on goodness or badness. And that was decent in the 2010s and arguably in the 2020s, but by this time, why don't we decouple that? Why don't we let the machines go handle the automation, and rather than have them try to make the assertions, have the output of our testing be more informative to us so that we can look at it as the humans and make the final judgment call. Oh, wouldn't that make things potentially more robust and reliable in terms of the checking mechanisms? Ooh, so are the machines just testing? Are the machines testing things, or are they really just being used to check things? Maybe that's what we should have done all along. Oh my gosh. And so with this, once people started having this enlightenment moment, we saw the rise of replay as a primary mechanism for testing. And this is what replay would look like. You're a developer, you're building cool stuff. And so you're in your project and you make a change, right? And then it goes through the whole CI system. CI never dies. Yay, we still have jobs as DevOps, right? So it goes in, it builds, things kick off. And when things kick off, your automation loads that new version of the product that's been built. And what it does is, rather than run a test suite and give code coverage, that's so antiquated, that's so 2010s, it will smartly start to poke and prod and kind of meander through it almost like a spider or an explorer. It's spelunking through your app. And what it's doing is it's looking for differences since the previous version, right? Continuous integration, we kept building all these builds. So in the previous version, it mapped out all the behaviors and learned that. Then in the next version, it does the same thing. It maps it out and learns that. And then what it does is it does a diff. What was different? What was changed? Because you as a developer, on one hand, you had the intention of making a certain change. The whole point of testing is to determine, was that change right? Was it successful? So the whole reason we had a separate tester for the developer was to have a separate party come in and evaluate what that change was and if it was good or bad. So here we have modeled that with automation to say, hey, let's go have that figure out what the change is, because the AI technologies are so good with all of its learning sources, and we have this agentic thing going on where it can actually go with MCPs and gooses and whatever and just go figure out what it's doing. And so when it finds differences, it presents that to the developer in a good experience kind of way to say, hey, I checked on your, I saw this change, here's a quick video of it, here's what it looked in the old one, here's what it looked in the new one. And the developer can look at that view and say, thumbs up, thumbs down. And if it's thumbs up, everything's good, we've passed the test. But if it's thumbs down, oh shoot, developer has that immediate feedback, they need to go change that. That was the whole point of testing, fast feedback. And that's why replay with AI became so powerful. Over time, the AI got good not just at providing this experience, but also in becoming a bit of a recommendation engine. Remember I said before, it's the humans who are good at saying what's good or bad? Well, with all of that feedback, the AI started learning what was good or bad too. And so it wasn't perfect, but the AI could start recommending not only here's the change, but the AI could start saying, hey, I don't think this is good for these reasons. I've seen this in other apps and it was bad. And so this whole process started becoming even more streamlined. It's all about context and learning. So we've primarily been talking about test automation and pipelines and that thing. But automation went forward in other directions too. There was a lot of advancement with team automation. Cool stuff. What did this look like? One thing was automatic journaling. And I think this has already started happening in 2025. Say you're in a meeting and you're doing a lot of blah, 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 talking. I think there's a whole keynote about good meeting practices the other day. Imagine if not only all of that was recorded as transcript, but it went into this great knowledge base for your team, like Notion on steroids, right? And then rather than you have to go write wiki pages for all this stuff, it would just go into this knowledge base and you could kind of query it with prompts. Hey, what was that time we talked about this thing? Here you go, boop, right? And so teams become more efficient and less forgetful with this automatic journaling. Send this even further. let's say we're in a meeting and we're trying to figure out a particular new feature to add to our app. And we're talking about it and we're like, hey, I think it should be a widget like this. Imagine if your AI assistant, who's also in your meeting, renders a whiteboard and says, oh, you mean like this? And it throws up a drawing. No, I don't want it to be a square. I want it to be more hexagonal. Okay, weep, whoop, and it changes it. Right? Oh man, wouldn't that be sweet? Then what if you're talking with your team and you start enumerating features? And the AI agent starts writing it like a scribe, on a whiteboard. Not just a raw transcript, but actually trying to be intentional and thoughtful and make bullet points and stuff. And then what if you say at the end of the meeting, okay, hey, thanks, Mr. Agent, go add that as a JIRA ticket to our board. Boom, and it just does that. There's no meeting follow-up, no action. You can see, and it says, oh, it was ticket 1, 2, 3, 4, 5. Here's a link to it. Wow, now you as the human can go back and edit that ticket later, but you didn't have to take the time to stop in the middle of the meeting to go and create a ticket and fumble around and all that kind of stuff, right? Wouldn't that be awesome? Team automation. This stretches even further. Asynchronous demos. How many people work on a remote team where we're not all in the office together? That is a majority. Ha, big corp didn't kill it after COVID. Yes, I work remote too. One of the most frustrating things is everybody has to schedule a meeting and then Zoom in and then, hey Andy, you're on mute. Every time, right?
Or you're not on mute. Oops.
And then we have 2 hours of demo meetings and 3 hours of planning meetings and 15 minutes every day of stand-up meetings, and I'm just in meetings all day, which means I'm not in meetings because I'm not paying attention because I can turn my camera off and go work on my second monitor. Don't repeat that to my boss. But what if instead of having these agile ceremonies every 2 weeks where we sit for 2 hours and have everybody demo their thing and be on mute and have the thing broken, what if we used awesome production tech and recording technology and all these wealth of apps that we all now have, where a developer could record a quick demo video as part of the definition of done, and they slap that on the ticket. And so people could just kind of see what's going on in real time as like a stream of work. True Kanban, no gates. Ooh, maybe that could help us move a little faster, that we don't all have to wait to see a demo of something, we can give feedback faster. All of this summed up, now our team has this amazing knowledge base of all of the things. What if instead of a daily stand-up, everyone receives a tailored daily digest in the morning of what happened that day that was pertinent to them? And so instead of getting up in a meeting every day and being like, here's what I did yesterday, here's what I'm doing today, no blockers. What if instead there was a direction of, hey, we don't all need to go around the room and do this. We already know what we're all working on. Let's direct y'all to where you need to go. I think you should have this conversation with this person about this product or this problem or whatnot. So really, really cool stuff that has happened. Autonomous tools really upended the software game because that's the world that I want to live in. We all know about Agile. Agile is not dead, but changing, just like DevOps. In 2035, my predictions is that Scrum is nearly out of date and dead. Waterfall is back because we can move more quickly, and they renamed it to Whitewater. Kanban took over because it kind of already is now, and we have the rise of async Agile, also called no Agile, because you don't need all these ceremonies. You can just get work done and share it collaboratively together with the power of team automation. Discovery, formulation, automation. This is pretty much the development process no matter what. So there are challenges like cost, training, but quality is still human-oriented. We reimagined automation for both testing and collaboration today. And we should be thinking less about writing code and more about building behaviors. It's more about product development, not just code monkeying. So let's be creative. Clearly, I'm not from 2035. I'm still from 2025.
No.
I know, right? But I wanted to challenge you all to think what the future could look like. So I'm hoping these ideas could be things that we can build together, because I think these things would be very, very valuable. So thank you again very much. My name is Andy Knight. I'm the Automation Panda. Let's reimagine automation together.